Hello, this is Danu, and today I'm going to go over the paper published in Nature in 1896 in volume 53, entitled On a New Kind of Race, written by Wilhelm Conrad Röntgen. Let's get started. In this paper, Röntgen discusses his newfound knowledge of a new kind of ray that he discovered when a compound called barium platinocyanide, which is this compound, fluoresced during his experiment with Crookes tube and cathode rays, as written in the Stanford paper written by Alexis Esmus in the early history of X-rays, is written here. Platinocyanide screen fluorescing in his laboratory as he generated cathode rays in a Crookes tube. As he was experimenting with cathode rays in the Crookes tube covered in black cardboard here, which is opaque to UV light, he noticed that barium platinocyanide put aside in his laboratory fluoresced, leading him to conclude that some agent other than the UV light is capable of penetrating the black cardboard. Since then, Röntgen conducts several experiments with different material bodies to test the penetration ability of this new agent, which is X-ray. This investigation involved materials such as paper, printer's ink, cards, and woods, which all failed to resist the transparency of X-rays, whereas materials like tin foils and aluminums and glass plates and lead glass, they were quite greatly reduced the fluorescence of those barium platinocyanides, which means that they were quite good in reducing the penetration of the X-rays. And then Röntgen experimented with a human hand, which the bones of a hand appeared dark, whereas the surrounding tissues, like skins, only had faint outlines when held before the fluorescent screen, as written by Röntgen in this paragraph. He then tested the different metal plates, including copper, silver, lead, gold, and platinum, which allowed some rays to pass, but that only happened when the metal plates were thin. When the metal plates were thick, they were also greatly adequately reduced the transparency and permeability of those X-rays. With these experiments, Röntgen could conclude that the density of the material bodies affect their permeability from X-rays. But further experiment with the Iceland spar and quartz, aluminum, glass, and Iceland spar, glass, aluminum, and quartz revealed that the density wasn't the only factor that determined the permeability, because the Iceland spar showed much less transparency from the X-rays rather than the other bodies like glass, aluminum, and quartz, though all of them had the approximately same density. So this was the first part of Röntgen's paper on a new kind of rays, which is the ability of X-rays to penetrate through materials. And there are two other parts about X-rays that Röntgen discovered in this paper, but due to time constraint, today I'm only covering the only first part. So if you want to discover about the other two findings, keep in tune with my channel. Thank you and see you next time.